Hi there. Welcome to my channel KM90 Fundamentals by Dr. Abhi Chakravarti. So today we will be going to discuss. I am Dr. Abhi Chakravarti. Today we will be discussing the robotics applications in food processing and handling, and we shall see with the help of some examples how we can transform various matrices to get the relevant information. Suppose in these questions we will study first if an object is kept on a desk or a plane and there is an end effector, and from the end effector a camera is attached and the camera sees the object, how it will actually transform with the help of matrices, how it will locate that object with the minimum possible distance, how the camera is attached relative to the end effector, how the end effector is attached relative to the robotic arm, and how the robotic arm, how much it will move to basically locate such that the end effector grabs the object. So how much the camera will check or correct the coordinates so that basically the robotic arm and the end effector in a combined fashion grabs the object in a minimum possible or shortest possible distance. So these are the examples. We will learn this thing with the help of examples. First of all, we study the homogeneous transformation matrix. What are homogeneous transformation matrix? We will see in this example. They are basically the combination of rotation matrix and the translation matrix. So this is the translation part, this is the rotation part. So in this question it is given a camera is attached to a gripper in a robotic arm. The camera can focus on an object to determine its frame relative to the camera. So formulate the transformation matrix for the object relative to the robot arm using the matrices given below. So here it is asked that I have to form an object that is arm. So arm T object I have to find out, but it's not here. So we are given cam T object, camera transformation to object. We are given gripper transformation to camera and gripper transformation to arm. All this are 4x4 matrices with first 3 rows and 3 columns for the rotation matrix. This is the translation part, and this is the perspective matrix, and this is the scaling matrix. Now we see the solution, how it is done. First of all, before doing the transformation matrix, I would like to introduce you to find out the inverse of a 4x4 matrix with the help of a Gaussian elimination for doing it the same. So A transformation matrix B, ATB is given as A1 B1 C1, A2 B2 C2, A3 B3 C3 with linear translation part as Px Py Pz, and we are having perspective matrix as 0 and scaling matrix as 1. Now for this inverse A transformation matrix B inverse, we change these columns into rows. So A1 A2 A3 now become row matrix. This column matrix B1 B2 B3 becomes again row matrix. C1 C2 again C3 again to row matrix C1 C2 C3. Now the perspective matrix remains same 0 0 0 0. What is perspective matrix? Perspective matrix is how the camera, how the end effector is projecting the object, how the projection is falling of a particular object on a plane. So this is basically defined by perspective matrix, and the scaling matrix here the scaling remains same, so it's 1. And the linear translation part, how much translation it is happening, such that how much linear translation is happening apart from rotation of the robotic arm to grab that object. So now all this column matrix changed into row matrix. Now Px is multiplied by A1, so minus negative in brackets Px A1 Py A2 Pz A3. In a similar fashion, Px is again multiplied to this column matrix B minus Px B1 minus Px B2 Py B2 again Pz B3. Again Px is multiplied to this column matrix, then minus Px C1 Py C2 Pz C3. In this way we find the inverse of the matrix. Now we are given cam T object is given as 4x4 matrix, grip T cam is given as this matrix. Now we write down what are given. Given is our grip T cam, we write it down. Cam T object, we write it down. Again grip T arm is given here. If I write grip T arm, if I write arm T grip, that is inverse of grip T arm, what I get grip cancels, camera cancels, we get arm T object. which is required and asked in the question. So in this way we multiply such that the even quantity or the like quantity cancels out here, and we get the required transformation matrix. So after doing this matrix multiplication, arm T grip, we get arm T object as this -1 0 0 -2, this 4 cross 4 entire matrix. So in this homogeneous transformation matrix, we consider the figure of the robot with a body frame B and a space frame S. Then the configuration of the body frame with respect to space frame can be found out. Now hi everybody, I want all of you so friends to see the next question. What is the next question is that we will again introduce here for the missing elements the following frame of representation for an object in space. So in this question, just as 4 cross 4 matrix is given, we will also show the orientation and position of frame with respect to XYZ, OXYZ. So there are two frames basically. One is the spatial frame where the object is kept, and one is the end effector frame from where the object is to be picked up or placed. So both of the frames are different. If we can name the two frames like 0XYZ, and other frame is ABC or UVW as you wish. So to find this location, how to locate these two frames and to conjunct them with a similar kind of a thread, we need to find out the missing parts in this 4 cross 4 matrix. How we can then we can relate it. So these 4 cross 4 matrix can be represented as cos theta XU. If I take the other axis apart from XYZ, the other axis is UVW, the other will be XYU. So other axis, take other axis as UVW, then cos theta XU, cos theta XV, cos theta XW. Again in the second row, cos theta YU, YV, YW, cos theta ZU, ZV, ZW, and so on. So when we write, if we construct a table XYZ and the UVW, we find the angles here. Angles UV, V is 90 90, 180 degree, 180 90 90, and here is a question mark. So this needs to be found out. How we can find this out? So we draw the coordinate system XYZ with the linear distance 5ZT UVW, and we write the linear matrix as like this. Now we write down the angles. So how are we going to find out the angles? Angle is 0. This means the theta between the angles is 90 degree mutually perpendicular. That's why it's becoming 0. Where in case negative, it means at the 180 degree. We write down the angles and then the correlations like X and U. So basically what we find out with X and V, it is orthogonal in orthogonal direction. With X and W, it is actually horizontally opposite direction. When we write this again Y with V, it is actually orthogonal. So Y with V is basically orthogonal. This means these three UVW are mutually perpendicular axis. So U will be perpendicular to the V axis. Now this we can find out the angle between X and U, which is basically nothing but orthogonal 90 degree. Y and U is 0 degree, and Z and U is again orthogonal. So the second column matrix, while we write this 90 degree, then cos 90 value is 0, cos 0 is 1, cos 90 is 0. So this is a column matrix. In this way we saw that how we can find out the missing elements, that is 0 1 0, with the help of some transformation matrices. Now if we see for the second type of the questions like location of vertices, that is 1 1 0 0 1 0, we solve for new coordinates after undergoing first a shear of 2 units along X and second a shear of 2 units along Y. See, in this type of question, vertices is given 1 1 0 0 and 1 0. We create a triangle. After that a condition is given in this type of questions. How we solve it is that a shear of 2 along X is there. So Sx is equal to 2. We write down X new. What will be X new? The X new is changed. X new will be X old plus Sx into Y old. Sx into Y old. So Y new is what? Y new is actually Y old, the original, because since the change is happening in the X axis only. Now then X dash will be 1 plus 2 into 1 is 3, Y dash is 1, then because 1 1 becomes equal gives to 3 1. So this is basically the fundamentals behind it. So now if we go to the other part, on the other hand, if we write down these vertices 1 1 0 0 and 1 0, we find out when we apply this transformation matrices 3 1 0 0 1 0 and 1 0. So we get the 0 0 remains the same as earlier with no effect of shear. The 1 0 basically there is some effect of no, the shear effect gets nullified since the x new is x old, which is 1, and sx into y old. So y old was 0. So when xx is multiplied, it becomes nil quantity, and again it remains same. So only change we can see is there is in vertices 1 1. So it is effective on the vertices 1 1 only. So 0 and 1 0 0 and 1 0, the other two vertices are untouched by the effect of shear of 2 along x-axis. If we consider similar effect for the shear of along y of 2, then if we write sy is equal to 2, then we can find out that x new is x old, y new is y old plus sy into x old. So what we find is there 1 1 changes into how much? 1 1 is changing, 1 1 is changing to 1 3. Basically it is changing to 1 3 with the effect on it. The 0 0 vertices again remains unaffected, it remains 0, and the 1 0 vertices, if we write y new y old, y new is what I don't know, y old is my 0 here, and sy into x old. Sy is my 2 times into x old. The x old is my 2. So basically x old is my 1, so 2 into 1 is 2, then y new is basically nothing but y new is 2. So so what happens is that the 1 0 vertex transforms into 1 2 vertex. So when the shear along y of 2 is introduced, two vertices are affected, that is 1 1 1 vertex, and the second is the 1 0 vertices, changing them to 1 3 and 1 2. Now that's how we can apply matrices of normal homogeneous transformation matrix to evaluate the kinematics of robotics. Now if we saw the rotate the vector v equal to 5 I cap 3 j cap 8 k cap by an angle 90 degree about the x axis and solve. See, this kind of questions are basically will help you to locate the vector by an angle of 90 degree of rotation. So when the rotation is about an x axis, by the inherent formula, there is a formula when rotation is along x axis, my first row and first column elements are 0 apart from the at most first entity, that is first row first column entity, that is 1, then all other are 0 0 0 0, and then cos theta minus sin theta sin theta cos theta. So if we write these values, that is 1 0 0 and all these entities here with projected vector 5 by 3j 8k and multiply it, we get a rotation matrix of 5 minus 8 3. So similarly, if we see the rotate another question is given like rotate 0.25 by 90 degree about origin. How to do that? About origin it's written so when something is about origin, we need not write the 3 cross 3 matrix, it will suffice with 2 cross 2 matrix here. So that is cos theta minus sin theta cos theta. Since the angle is 90 degree, the theta has become shifted to 90 degree. We rotate the 0.25, so we write this as column matrix and we multiply, we get minus 5 and 2. So these are some questions with the help of which you can realize how the end effector, manipulator and camera are connected in the help of robotics application in food processing. Thank you all for this video. Keep watching and I will be coming soon with my next videos. Bye.